Okay, so I'm going to do just a brief overview of Chapter 3. What we're after here is if a point had feelings, what would it feel based on all the forces acting on it? Um, we're going to use the method of components, and I will let you know when you're doing your math. Tables are very helpful with this. Um, we have multiple forces acting at a point. So I've got F1 coming in here, I've got F2 coming out, and I've got F3 pointing horizontally to the left. So in general, the steps for solving any of these kinds of problems is you want to calculate and find the sum of the forces in the X. And your book is going to use sigma, the Greek letter sigma for this. And it's going to do F with a subscript of X. At some point it'll change to a subscript of H, but don't worry about that for now. It's the same thing. Step 2 is we want to calculate and find the sum of the forces that are in the Y direction or that are acting vertically. Again, we're going to abbreviate that by the sum of the forces in the Y. Then we want to go ahead and calculate our resultant, which is capital R in your book. Again, think about the Pythagorean theorem. You've got horizontal components and you've got vertical components. How do you find your resultant or your hypotenuse of a triangle? If you know the horizontal and vertical, you're going to take the square of the sum of the forces in the horizontal and add it to the sum of the square of the forces in the vertical and take the square root. That is your magnitude of your resultant. Remember magnitude. Magnitude has units. It might be pounds or newtons. Last thing we want to do is actually calculate its direction, and that's theta. Again, it's always with respect to an axis, so we either use x or y. If you're going to do it with respect to the horizontal, which is where we live usually, it's going to be inverse tangent of the sum of the forces in the y divided by the sum of the forces in the x.